Well, hi everyone. I've got a very interesting video for you today, I think, and this is really right up my alley within the specialty area of geotechnical engineering. I've had nearly 40 years of engineering experience as a geotechnical engineer, and I've got extensive Department of Transportation bridge project experience under my belt. So this is an amazing story for not only what happened, but how the information about what happened came to light. So I'm going to go through what happened and get into why the DOT ignored persistent and obvious warnings from the contractor and engineers working for the contractor that this wall would eventually fail. And the DOT turned a deaf ear and a blind eye to the whole thing, and repeatedly going back as several years before the wall failure, throughout the time period that this wall was built, they just simply refused to acknowledge what I think was the obvious. So we see a few photos here of the wall failure. This is a mechanically stabilized earth retaining wall. Over 300-foot section failed overnight on March 25th, 2021. Now, where things get interesting is there's a local CBS News affiliate in Philadelphia, and this reporter, Brandon Goldner, I think he was relatively new in the TV news business, but he had a natural curiosity about how something like this could have occurred. So on his own time, he did investigative research over a period of 2 years and requested public information, public records about this wall failure, and he just got it. He did a news story about this last week. And, as an aside, I really applaud that type of initiative. I think this country needs more people like that in whatever jobs they have. In the last few years, there's a lot of talk about quiet quitting and just doing the bare minimum, which I've never been in favor for in terms of work. If you're a person that shows initiative and has a natural curiosity, you're going to learn a lot of things. Your job's going to be way more interesting, and you're going to bring tremendous value to whoever you're working for. That's going to pay off in the long run. That's my view of things. Now, this reporter brought in Grady Hillhouse from the Practical Engineering channel to review this information and offer some opinions. And the reporter asked Hillhouse, why did the DOT ignore persistent and obvious warnings from the contractor that this wall was going to fail? And I'll just play you what he said here.
To me, that was one of the most surprising parts of this whole story.
I don't know how much DOT experience Mr. Hillhouse has, but I've got over 25 years of DOT experience with bridge projects, as I mentioned. Now, based on my DOT experience, I'd say there's a lot of hardworking, dedicated people at these departments of transportation throughout the nation, at least in the areas I've worked. But there's also a lot of slugs. In my experience, there's too many, I'll put it that way, that shouldn't belong in these organizations. And what I mean by slugs are people that aren't motivated, they do the bare minimum, they have a chip on their shoulder, or they're just generally incompetent. So I'll let you decide for yourself whether any of these situations apply here, but it's just a ridiculous situation that happened here in New Jersey. So one of the things I'm going to get into is, how does this happen? How do DOTs ignore warnings from experienced contractors, other experienced engineers, and go about their merry way, oblivious to the risks? Part of it comes through the siloed nature of the work. You typically have the DOT as one silo. You have the project designer in another silo. Now, sometimes the designer is DOT staff, but more often than not, it's an outside private consultant, which was the case here for the overall design of this retaining wall. And then the final silo is the contractor. And unfortunately, I've seen this a number of times where the DOTs think they're only doing their job if they pretty much just bust the chops of the contractor from beginning to end throughout a project. And they seem to think that the contractor's out to get them at every turn, and the DOT's the keeper of all things quality and proper, and the contractor's just going to try and get away with whatever he can to cut corners and save money. And that's just not been my experience. Most of my work in the last 25 years on these DOT projects has been done for contractors. I'd say 95% of my business in my company comes from working with contractors. And the contractors I work with are extremely dedicated and want to produce a high quality product. They don't want to have any problems. They don't want to end up in lawsuits. They don't want to get a bad reputation. This work is extremely competitive. So their reputation means a lot. So I don't agree with this adversarial mindset that I see in too many instances on these projects. Now let's look at the design of this wall. It has several components. You have this gray in the upper right-hand corner, which is the retained fill. And then in front of that, you have the mechanically stabilized earth wall. And that consists of reinforcing strips within a select backfill zone. And you have multiple layers of these strips to connect to a concrete facing panel. Then you have the fill slope below that, and it's 2-to-1 slope, so it's rather steep. And then that fill material in the slope rests on a column supported embankment system. These are what are called rigid inclusions. They're essentially auger cast piling, where an auger drills through the soil, and as it gets to the bottom and starts to come back up, it injects grout to form a column. And sometimes these rigid inclusions have steel reinforcing, sometimes they don't. In this instance, they did not have any extra reinforcing. Now, the area we're talking about for this project is in Bellmawr, New Jersey. The MSE wall is part of a interchange at I-295, I-276, and Route 42. Here's a Google Earth view. You see wall 22 pointed out there with the arrow. I mean, this wall was under construction for many years before it failed. Then there was a period of deconstruction and forensic analysis, and now they get to rebuild the thing. Now, it's going to cost them $92 million to rebuild this retaining wall. And as I'll discuss later in this video, the contractor pointed out what could be done to avoid this wall failure. It was going to involve some extra costs, and rightly so, because their designers were going to have to do additional work and produce additional or revised construction documents. And it was going to cost $70,000. And the DOT came back and said, well, if you want to do that, you can do it on your own expense. We'll approve the material change, but we're not going to pay for any part of it, which was, extremely short-sighted. They traded a $70,000 expenditure for a $92 million expenditure before it's all said and done. And, I don't know what kind of accountability is going to come out of New Jersey DOT relative to the people involved with this project. I don't know too many people in the private sector who could cost their agency $92 million and a lot of embarrassment and loss of reputation without having some serious repercussions. I have no idea. Seems like accountability is not high on the list these days with government entities. And some of the other players, Dewberry, the engineer of record, they were responsible for the overall design of this retaining wall. Then you have South State Inc., which is the general contractor who gave New Jersey DOT repeated warnings that they were using the wrong material for this retaining wall, and that it should change to a more freely draining material to avoid a future failure of the wall, which ultimately occurred. Then you have Menard Group. They designed the column-supported embankment. And then you have the Reinforced Earth Company, who designed the mechanically stabilized earth wall. So Menard and Reinforced Earth Company were sub-consultants to the prime contractor here, SSI, as I'll refer to them. And that's typical in retaining wall design. The designer, say for the MSE wall, is only responsible for that discrete portion of the wall. And then somebody else is responsible for what they call global stability, so analyzing the thing as a whole. So the Reinforced Earth Company was responsible for designing the MSE wall. Menard was responsible for designing the column-supported embankment system. And then Dewberry was responsible for the overall design and make sure it was going to work, including global stability. So here's some shots of the banners from these websites: New Jersey Department of Transportation, Dewberry. Apparently they have over 2,500 employees, offices throughout the country. Then they did over $700 million in business in 2023. I've never heard of them, but that doesn't mean anything. I operate mostly in the Midwest, so I don't know if these are pretty much East Coast, West Coast projects for these people or not. Then you have South State, as I mentioned, Menard, and Reinforced Earth. You also had a few other players as a subconsultant to the prime contractor. You had a Wang Technology that installed the inclinometers and other instrumentation to monitor the condition of this slope throughout construction. And then you've got New Jersey Department of Transportation Bureau of Materials. They were responsible for material testing, the fills and other materials that were used to construct this retaining wall. And then you have both New Jersey and IH engineers and AECOM responsible for construction observation while this wall was built. Now, as I mentioned, this wall failed exactly in the way that the contractor said it was going to fail, and that was a global stability failure. Anytime you see loss of material at the top of the slope and a scarp forming, which is a vertical or near vertical face, and then a bulge of soil material at the base of the wall, well below the bottom of the wall, that suggests you have a global stability failure. It's obvious. Here we see a cross-section of the failure. The red line shows the post-failure configuration of the slope. So you had a loss of material at the top. You had a lot of tilting of the MSE wall face, and then you had a big bulge of material piling up at the base of the slope as it failed. Now, as I mentioned, there was correspondence from the contractor, most pointedly and earliest in 2018, saying you're using the wrong material for the backfill. You're using what they call I-11, which is a pretty fine-grained sand that doesn't drain very well, and the contractor thought they should be using I-15 gradation material, a little bit coarser, has better drainage characteristics. So this type of correspondence and notification went on back and forth throughout the duration of the project. And then on March 24th, 2021, as the wall began to fail, the contractor issued this letter to the DOT, and it summarizes all his prior warnings. I mean, it's an I told you so letter, and it was appropriate for the contractor to send this, in my opinion. I mean, it's just ridiculous that these warnings were overlooked and disregarded. So you can see reference here to them mentioning in January of 2018 that was the wrong backfill material to use, and that their specialty consultant for the column-supported embankment agreed that this was going to be problematic material if it wasn't changed. So again, the yellow is this I-11 backfill. The contractor said that needed to be changed to a coarser gradation that would have better drainage characteristics. Here's some additional details: that there were noted instances of wall panel displacement. The inclinometer readings showed movement of the foundation soils, which resulted in tilting of the backfill and the wall elements. You got to appreciate this paragraph. It is not difficult to understand stacking loose sand 11 to 12 feet in height, then surcharging it with a 30-foot plus embankment in a three-sided condition presents inherent stability issues as warned. It is then no coincidence the lateral movement is in the direction without constraint. The open face is the path of least resistance. And in this March 25th, 2021 letter, which was issued just a few hours before the wall ultimately failed, they point out that Menard expressed serious concerns associated with lateral stability of the I-11 fill under MSE wall number 22. This is the wall that failed. And they said they performed additional analysis that showed this wall was going to fail, unless there was a change in the backfill material. So this part of the letter references the fact that New Jersey DOT considered that these early signs of wall distress were due solely to the lack of proper placement and compaction methods of the backfill material by the contractor. And what Menard points out is, no, these movements are completely consistent with our analysis in that you're using the wrong backfill material. Now, as I mentioned, this letter went out from the contractor to New Jersey DOT on March 24th, 2021, less than 12 hours before the wall had a massive failure or catastrophic failure. Fortunately, no one was injured as a result, but it could have been very different, especially if there had been traffic over the top of it. So you can see the red highlighted area is the area of tension crack development in the roadway section. This roadway is on the top of the MSE wall, and the contractor references the DOT's prior responses. You know, it mentions the department disagrees with the circumstances of the wall panel resetting. So it cost the contractor $65,000 to reset these wall panels early in the process of construction. And the DOT said, that's your problem, we're not paying for it. They also point out that The contractor told them this is the wrong fill material. And again, New Jersey DOT said, no, we're fine with it. Our consultant Dewberry reviewed it. We're sticking with that I-11 material. Now, this is a pretty interesting statement, and again, I think it's appropriate. Seems to SSI, Menard, and Reinforced Earth Company limited liability language provided in New Jersey DOT responses has no effect on the ongoing geotechnical realities. New Jersey DOT now has a significant issue to deal with in spite of the very detailed record of warnings beginning with this correspondence on November 2nd, 2018. So in other words, the DOT's designer, Dewberry, was ultimately responsible for this wall. They had the responsibility for checking the global stability. The specialty consultants working for the contractor had a very narrowly limited scope of design responsibility relative to either the MSE wall or the column-supported embankment. So in other words, this is New Jersey's baby all the way, and the contractor warned them repeatedly. Okay, so the wall fails overnight on March 24th, 2021. Here's a view of the wall failure from a photo that's included in the forensic report that was done by Hardesty in Hanover. You can see the red highlighted area on the roadway section. This is above the MSE wall. That's in red. And then down below you see the green grass-covered slope that's just all bulged up, indicative of a failure that goes from the top of the slope down through the foundation soils, pushing material out beyond the original toe of the slope. So when I talk about global stability analysis, this is what's called limit equilibrium calculation. So you assume a trial shear surface, you break it into vertical sections, and you have to assign a soil unit density. And with the geometry, basically you determine the forces that are pushing the slope downward and the forces resisting that movement, including the available soil shear strength along that potential shear surface. And the types of failures that we're talking about that occurred here are a deep-seated failure. So whenever you have a deep-seated failure, that means you got a problem with your foundation soils. And in this case, those foundation soils correspond to the I-11 backfill that the contractor said needed to be changed to I-15 so it wouldn't retain as much water, would have greater shear strength available, and provide greater resistance and a higher factor of safety against a potential failure. So this is what the soil profile looks like. You have a superficial sand, an upper clay, a lower clay. The Merchantville Formation underlying these clay deposits is indicated to consist of hard silt and clay with medium to very dense interbeds of silty sand. So obviously you wouldn't be concerned about a potential shear surface going that deep. Now here's a cover of the report that was issued not quite a year after the wall failed. So this report was issued in January 2022, as I mentioned, by Hardesty and Hanover, a geotechnical consultant out of New York. And this describes their approach to the study. H&H followed a widely recognized practice for geotechnical forensic studies that includes data collection, technical study, engineering analysis, and development of this summary report containing findings and conclusions. And it goes on to say this was done to identify potential contributing causation factors and failure modes using a process of elimination. Now, I don't disagree that you have to be thorough and open-minded in these types of studies, but given the failure mechanism and the repeated warnings from the contractor and the contractor's specialty engineering consultants that this was going to happen, and it happened exactly how they said it was going to happen, it's pretty obvious. And I don't see that a full-blown forensic study taking nearly a year after the wall had failed was necessary. I did a search and found that New Jersey DOT spent $283,000 for Hardesty and Hanover to do this forensic analysis. That's a lot of money, especially considering that they weren't going to spend the $70,000 to do this construction right to begin with. But again, given how this failure mechanism was pretty obvious and consistent with exactly what the contractor said would happen, I think this study could have been done for about $10,000 and could have been completed within a month. But So you have to ask yourself, was New Jersey DOT being super thorough and examining all possibilities? Or is it a matter of them desperately hoping that a forensic investigation would uncover something somewhere that the contractor didn't do right? And I think the latter is a possibility, but there's no information in the correspondence that this reporter, as I mentioned earlier, Brandon Goldner, and I'll put a link in the description, but he posted the documents that he obtained from New Jersey DOT and the public records request, and includes hundreds of pages of emails, and this forensic report alone, 700 pages in length. But the H&H study did not get into the correspondence or that these warnings were obvious. They sidestepped that whole thing. I guess, I'm disappointed in these types of studies all the time, and it's not surprising because you don't necessarily want to throw your client under the bus. But I think a true forensic analysis has to just deal with the facts however they present. And in this case, the facts are the contractor told them repeatedly, along with their specialty engineering companies, that this wall was going to fail, and it did fail in the manner that they said. And there were many warning signs along the way. So I don't think it's out of line that this report could have included a summary that says, this is what happened, and there were multiple warnings consistent with what the contractor said would happen. I don't envy anybody getting paid $283,000 to write a report like that, but I think it's the correct way to go, in my view. And, that might be a one-and-done situation where they don't hire you again, but, otherwise it's left to reporters like Brandon Goldner or somebody like me coming along and just pointing out what's, in essence, the obvious. So this notion of the DOT spending extra money so that they could hang the contractor with extra responsibility or costs, I see in a small version with my testing of drill shafts for bridges during construction. There are instances where, I'll show you a quick video of what the CSL data collection looks like. We've got probes that go into steel tubes that are cast inside the reinforced concrete drill shaft, and we're sending an ultrasonic signal from one tube to the next, and we're able to identify areas of low density that might be weaker concrete or be gravel or a soil inclusion. And there are times where I identify a very small area that may have questionable quality concrete. And I may even say, yeah, it's small, it's right next to, in this case, tube number 1. If you try to core it, which is a common thing to do for identifying anomalies identified through cross-ultrasonic logging testing, is to perform a full-length core to get to that zone of interest, and it's usually at the bottom of the shaft. And I'll say in my report that it's probably not worth coring. I don't think you'll be able to hit it. And I see in several instances where they'll do the core anyway, they don't hit anything, and then they'll do a second core, presumably to hope that they intersect an area of poor quality concrete, because if it's good concrete in all the cores, the DOT has to pay for the coring. But if any poor quality concrete is confirmed through a core, then the contractor has to pay for all the coring costs. So it seems in some cases that extra holes are drilled in the hopes that the contractor has to pick up the tab for all of that investigation. So I'm going to go through what H&H, Hardesty and Hanover did for their forensic investigation. They did soil borings, cone penetrometer testing, that's the cone rig there, where you push a cone with electronic instrumentation and you get characteristics of the side resistance and tip resistance. You could classify the soils. You could also do pore pressure dissipation tests, so you could stop at a given interval and measure the time it takes for the excess pore water pressures that developed by pushing the cone into the ground dissipate. And so in that way you get a good idea of the drainage characteristics of the material. Here's a short video of just standard drilling and sampling. This is solid stem auger, just drilling a hole, and then we're getting ready for split spoon samples testing. In this case, we're measuring the energy to calibrate the hammer, as it's called. And this is what a split spoon sample looks like when it's opened up. Another type of soil sampling is with a steel tube, thin wall tube that's pushed hydraulically into the ground, and that's used to obtain high quality samples to perform very expensive testing, whether it's strength testing or consolidation testing, to determine the load settlement characteristics of that material. Then there's a bunch of laboratory testing that they did, index testing, strength testing, so on. So this part of the summary of the forensic investigation report indicates that Menard designed and built the column-supported embankment as they should have, consistent with the project requirements, and it was signed off by New Jersey DOT and their designer of record, which was Dewberry. Here's some photos from the forensic report showing exposure of these column-supported elements, these rigid inclusions. This photo shows a line of backhoes that were involved with removing the failed portion of the wall, and the forensic engineer for their report had people out there making a lot of observations about the in-place material for the wall and just how it was constructed. And they say, based on our review of the construction records, the construction practices followed by New Jersey DOT standard specification requirements for the MSE wall construction, that is, moisture content and density control practices, met the requirement of maintaining a minimum density of 90% of the maximum density. So in other words, they placed the material as they should have, they being the contractor. In a similar fashion, they found that the MSE wall was designed properly by the Reinforced Earth Company. It says, lastly, the design document concludes that Wall 22 design would function satisfactorily if built on stable ground. The design document assumes that others would be responsible for the design of the foundation soil. The design document assumes that others would be responsible for the design of the foundation soil's adequacy to support the wall without failure or excessive deformation. Others here refers to Dewberry, the engineer of record. And this is just a schematic of the MSE wall where you have these facing panels and you have either metal or geogrid reinforcement for select backfill, and then you have the other material that backfills the whole section. This shows a connection between these MSE strips and a wall panel. This is what it looked like after they removed them, so the wall elements were in place as they should have been. So let's get to the conclusions of this forensic engineering report by H&H. Based on our assessment of background information and the site and subsurface conditions, it is H&H's opinion that Wall 22's failure mode is complex and involves both vertical and lateral displacement of the I-11 material and a deep-seated bearing capacity / global stability failure. It is H&H's opinion that the following are the significant contributing factors that led to the failure. Let me just interject here. I don't think it's particularly complex. It failed exactly how the contractor said it would fail. The I-11 material used for the embankment and slope was not an appropriate material specification to support Wall 22 because of its poor engineering properties at high moisture content. The part that they leave out is that the contractor told them repeatedly that you shouldn't be using I-11 material. And New Jersey DOT and their designer of record didn't heed the warnings. And because that fill zone wasn't strong enough to distribute the loading properly to the column-supported embankment system, it indicates that as constructed, those elements should have been reinforced. But again, that's essentially, if you're going to use crummy material, you needed a beefier column-supported embankment system. They also mentioned the project site has a known chronic groundwater condition and showed previous indications of instability. Yes, throughout construction. And again, the DOT tried to insinuate that it was the contractor's fault for improper fill placement and other construction methods. The heavy precipitation observed on March 24, 2021 appears to have altered the marginally stable slope and ground improvement system on which the wall was supported. But again, there were instances of heavy rainfall in early phases of the construction of this retaining wall, and the contractor said, see, this is what I'm telling you, there's going to be a problem. And again, New Jersey DOT and their designer of record didn't act on those warnings. Now, in the information dump that came from CBS News that was released by New Jersey DOT, there's a response from Dewberry to these prior warnings from the contractor that this wasn't the right fill material and that there were going to be problems with the wall over the long term. So you can see this letter from Dewberry on October 11th, 2019. And essentially it says what they're doing is they're reviewing these contractor notices that there's going to be a problem if you persist in trying to use this I-11 sand backfill material. And what's interesting is the entire body of this response letter has been redacted. And you have to ask yourself, this is a technical matter. Either the designer agrees with the contractor's warnings or they don't. So the fact that this is redacted after the fact just leads to speculation as to what was in there. And I have no idea. But if I were to speculate, I would say that whatever was in there isn't favorable to Dewberry or to New Jersey DOT. You know, were they trying to dismiss this contractor by suggesting that they had bad motives, or that there was not a problem, but they are acting out of other concerns? Who knows? But I think it's really unfortunate that they saw fit to redact this information. I don't know if the reporter out there in New Jersey, what he thought about this redacted section of an important letter. Maybe he can take a second bite of the apple and revise one of his requests to get this full letter. But I want to touch on some of the really important early warnings here, and that is seepage exiting the face of the fill slope. And as a geotechnical engineer, I can tell you, if you design a slope and as part of your design assumptions that you've got a freely draining embankment and you think there's going to be seepage, or you notice seepage later on, that should be a showstopper that, hey, this isn't how I designed it. Because if you have seepage exiting the slope of a fill slope that you designed, and you designed it based on essentially dry conditions, the presence of seepage can cut your factor of safety in half. And a lot of times these embankment fill sections are designed to have just the bare minimum factor of safety of 1.5. So any seepage on a slope designed for a 1.5 factor of safety is going to reduce the factor of safety below adequate levels, and in many cases reduce it to a value below unity. In other words, there will be a failure at some point. So that warning was ignored by New Jersey DOT and their designer of record, Dewberry, apparently. So one thing I want to relate to here is, you know, how could the DOT ignore this stuff repeatedly? And I see this in my own practice. I test bridge foundations during construction. Half my work is for driven piling. The other half is for drill shaft foundations. And I've had numerous instances where my scope is just to merely perform the testing of the pile. I'm not responsible for what the design capacity should be, what the links should be, and so on. And there have been many instances where I've pointed out, hey, I've reviewed your plans because I'm getting ready to go test these driven pile foundations, and you've got a problem here. I gave a warning to a DOT about some large diameter closed-ended piling, and that size piling with a closed-in configuration had never been used in that state before. And the soil profile was a saturated sand, medium dense sand. And I also pointed out that, you know, you should consider looking at a smaller pile section, but with more piles so that you don't have this problem with installation. And they ignored me. And it turned out exactly as I said. These piles were extremely hard to install. At planned depth, they had half the required capacity, so they had to extend them to the 60-foot depth that I told them. I mean, I just did a back-of-the-envelope calculation. And this had gone through a third-party private design consultant and the DOT. And they ignored the warnings. This pile error cost them over $1 million because to get additional piling was very expensive. This was not cheap pile at 3 foot in diameter. There were delays on the project. And the funny thing was, there was a sister bridge just an eighth of a mile down the road in the same conditions, the same type of pile, the same required capacity. And they saw firsthand that their design didn't work on the first bridge. And they're like, let's see what happens on the second bridge. I just could not believe it. And of course, they had the same problem. And this happens in my practice about every other month, where I give really solid advice based on my experience. And it's not even my scope to point out their design errors. I'm trying to help out the contractor. I feel like I've got a broader responsibility to the taxpayers. And, you know, a lot of these bridges that I'm involved with are replacement bridges. The vast majority are. And so when they take an existing bridge out of service to build a new one, the locals there often have 45-minute or longer detours. These are big impacts. So if you extend somebody's detour of 45 minutes or longer for an extra 2 months, it's a big deal. It starts affecting kids riding buses to school, people trying to get their medicine delivered from delivery services, that sort of thing. So I noticed that the older I get and the more experience I have, it seems like people are less likely to listen to me. And for a while, I thought that was just kind of an ageist thing. They were dismissing me for whatever reason. But now I've realized that this is baked into the cake at a lot of DOTs. They just have the wrong attitude, quite frankly, in some of these instances. So hopefully that'll change. It'll be interesting to see what kind of pressure is brought to bear for accountability with New Jersey DOT in particular. You know, $92 million is not chump change, and $72 million of that's coming from Federal Highways Administration. So again, U.S. taxpayers are going to have to foot the bill for something that should have never happened if they'd simply listened to the contractor. And it's not the instance of the DOTs ignoring me. You know, I think the other part of it is they tend to dismiss what I'm trying to tell them because I'm working for the contractor, and anybody involved with the contractor is sometimes unfortunately considered to be suspect. You know, they just dismiss it out of hand at the DOT that, hey, this is coming from the contractor, we're the designer. And by the way, a lot of these designers for bridge foundations never get in the field or seldom do. I mean, if they did, they wouldn't have these type of errors that I see repeatedly. So I don't know, if I had Dewberry's responsibility, I would have had people there on site the whole time. In the past, I've had design responsibility for MSE walls, the global stability analysis where a vendor would design the MSE wall itself, but they don't have the licenses or the insurance to do global stability analysis, so they come to somebody like me. I don't do that work anymore, but when I did, I would insist on being there to do construction observation, because if I wasn't there to see how the material went in relative to my design assumptions, I was essentially giving them a blank check on liability. If something happened, it would come back on me. So, you know, I don't know to what extent Dewberry, if at all, was out there during construction, but they certainly had an opportunity to go out there when these multiple incidences of distress were revealed. So hope you found this one to be interesting. I think there's more news to come out of this situation here in the coming months as they complete the reconstruction of this retaining wall. I want to send a shout out to the channel members. I really appreciate your ongoing support. I also want to send a shout out to those of you who provided super thanks. That's another great way to support the channel. So let me know what you think in the comments section. Do you like these deeper dives on geotechnical related issues? You know, I feel like, you know, I don't want to sound like a broken record about calling out problems on projects, but I genuinely want things to get better. And I see instead that the same mistakes are made on job after job throughout the country, and it needs to get fixed. We don't have a lot of extra money to be wasting on simple mistakes or mistakes that could have been readily rectified. So thanks very much, everyone.